Good morning to everybody. We will have to force some. If F is a mapping from R to R, F is a mapping from R to R defined by 4 power x by 4 power x plus 2, 4 power x by 4 power x plus 2, then show that f of 1 minus x equal to f of 1 minus x equal to 1 minus f of x. F of 1 minus x equal to 1 minus f of x. Hence deduce the value of f of 1 by 4 plus 2 into f of 1 by 2, 2 into f of 1 by 2 plus f of 3 by 4. First of all, what is asking is, prove that f of 1 minus x equal to 1 minus f of x. So how to prove? We will take LHS first, that is f of 1 minus x. What is f of 1 minus x? So wherever x is there, we need to substitute 1 minus x. Means 4 power 1 minus x by 4 power 1 minus x plus 2. Now if I simplify this, 4 power 1 minus x, I can write 4 by 4 power x. By denominator, 4 power 1 minus x is 4 by 4 power x plus 2. LCM, if I take 4 power x from the denominator, numerator as it is 4 by 4 power x. By denominator, I will take the LCM of 4 power x. So this becomes 4 plus 2 into 4 power x. 2 into 4 power x. This 4 power x cancels. Left over is 4 by 4 plus 2 into 4 power x. If I take 2 common, 2 plus 4 power x. If I take 2 common, it becomes 2 plus 4 power x. 2 plus 4 power x. 4 by 2 into 2 plus 4 power x. This is what LHS is. I will leave like this. Next we will go for RHS. Then if both of them are giving the same answer, then I can say LHS equal to RHS. So we will keep it like that. Then we will go for RHS. What is RHS? RHS is 1 minus f of x. 1 minus f of x. 1 minus f of x. That is 1 minus f of x is 4 power x by 4 power x plus 2. F of x is 4 power x by 4 power x plus 2. LCM of these two is 4 power x plus 2. 4 power x plus 2 is LCM. So here I will get 4 power x plus 2 minus 4 power x. So 4 power x cancel. So left out is 2 by 4 power x plus 2 by 4 power x plus 2. Now coming to the denominator, we can cancel 2 times 2 jar. Coming to the LHS. So now LHS equal to RHS, both are 2 by 2 plus 4 power x plus 2. Therefore LHS is equal to RHS. LHS is equal to RHS. Hence LHS is equal to RHS. Hence LHS we got 2 by 2 plus 4 power x. RHS also 2 by 2 plus 4 power x. Therefore LHS is equal to RHS. Hence so finally what we got is f of 1 minus x equal to 1 minus f of x. F of 1 minus x equal to 1 minus f of x. F of 1 minus x equal to 1 I need to find the remaining value f of 1 by 4 plus 2 into f of 1 by 2 plus f of 3 by 4. For that, I will take this. Hence, reduce this. I need to take this and I need to put that. Now, let x equal to 1 by 4 what happens? X equal to 1 by 4 is equation what happens? F of 1 minus 1 by 4 equal to 1 minus f of 1 by 4. 1 minus f of 1 by 4. Implies 1 minus 1 by 4 is 3 by 4. So f of 3 by 4 minus f of 1 by 4 will become to this side becomes plus f of 1 by 4 equal to 1. Equal to 1. This is equation 1. This is equation 1. Say in this time let x equal to 1 by 2. X equal to 1 by 2. Then this becomes f of 1 minus 1 by 2 equal to 1 minus f of 1 by 2. 1 minus 1 by 2 is f of 1 by 2. And this minus f of 1 by 2 comes to say plus f of 1 by 2 equal to 1. Means 2 into f of 1 by 2 equal to 1. Equation 2. Solve 1 plus 2. Simply 1 plus 2 because we need f of 1 by 4 plus 2 into f of 1 by 2 plus f of 3 by 2. So if I do 1 plus 2, I will get required. 1 plus 2, that is f of 1 by 4 plus 2 into f of 1 by 2 plus f of 3 by 4 equal to say 1 plus 1. 1 plus 1 is, so the final answer is 2. Like this, we can solve the functional sums. Next one. If f of x equal to cos of log x, then show that f of 1 by x into f of 1 by y minus 2 into f of 1 x by y, f of x by y plus f of x y, 2 into f of x by y plus f of x y equal to 0 minus, not 2, sorry, half into f of x by y plus f of x y equal to 0 will is to 2. How to do? Simple. He is giving f of x equal to cos of log x. Here we need to know about the log formula and cos theta formula. Log of a plus b is log a plus log b is log of a into b, and log a minus log b is log of a by b. First thing. Second thing, cos of a plus b equal to cos a cos b minus sin a sin b. Cos of a minus b equal to cos a cos b plus sin a sin b. Cos formula you know, log formula. How to do? First of all, I will find f of 1 by x into f of 1 by y. Is asking f of 1 by x into f of 1 by y. What is f of 1 by x? Wherever x is there, I need to substitute 1 by x. So cos of log of 1 by x is nothing but log of 1 by x is x power minus 1 becomes cos of minus log x. But cos of minus theta is plus cos theta. Cos of minus theta is plus cos theta. So f of 1 by x is again cos log x itself. Like f of 1 by y. F of 1 by y. Cos of log of 1 by y. 1 by y is minus log y. Minus cos of minus theta is again minus cos theta plus cos theta only. So becomes cos of log y. Cos of log y. So f of 1 by x is again cos log x itself. F of 1 by y is again cos log y itself. Next. Coming to f of 1 by x. So f of x by y plus f of x y. What is f of x by y? F of x by y. I am writing separately, then I will substitute in the lecture. F of x by y. What is x by y? means just now I told log a minus log b. So it becomes cos of log x minus log y. Cos of log x minus log y. Now this is cos of a minus b formula. Cos of a minus b. What's the formula? Cos a cos b plus sin a sin b. Cos of a minus b formula is cos a cos b plus sin a sin b. So sin of log x into sin of log y. Next, f of x into y. F of xy, x into y is cos of log of xy. Now log of a means log a plus log b. So becomes cos of log a means log x plus log b means log y. Now this is b if I am taking. This becomes cos of a plus b. Cos of a plus b becomes cos a cos b means cos of log x. Cos a cos b means cos of log y minus cos of a plus b is cos a cos b minus sin a sin b. Cos a cos b minus sin a sin b. So sin of log x into sin of log y. Now if I add these two gets cancelled, becomes 2 cos log x into cos log y. If I substitute in LHS, if I substitute all these values in LHS, what happens? What is LHS actually? What is LHS? F of 1 by x. LHS is f of 1 by x is nothing but cos of log x. Cos of log x into f of 1 by y. Cos of log y minus half into f of x by y. That's all you got. Cos log x into cos log y minus sin log x. This is plus sin log x into sin log y. Sin log x into sin log y minus plus f of xy. Xy is this cos log x into cos log y. Cos log x into cos log y minus sin log x into sin log y. Sin log y. Now if you observe within the bracket, sin log x sin log y minus sin x log x sin log y cancel. Now what is left out? Cos log x cos log y minus half into left out is cos log x into cos of log y minus half into this is cos log x cos log y plus cos log x cos log y. 2 cos log x log y. 2 cos log x into cos log y. 2 gets cancelled. Left out is cos log x into cos log y minus cos log x into cos log y. So this is cos log x into cos log y as is. By cancelling half and 2, it becomes minus cos log x into cos log y. So left out is cos log x into cos log y minus cos log x into cos log y. How much? 0. Therefore LHS is equal to RHS. Therefore LHS is equal to RHS. Yes. Next two. Now this exercise is over. Next we will discuss some functions. Different types of functions. Previously we discussed kinds of functions. Now we will discuss some different functions, types of functions like even function, odd function, mod function, logarithmic function, arithmetic function, exponential function. Like these some different functions we will discuss their domain and range. Then go for the next exercise called domain and range. Now we will discuss types of functions. There are different types of functions. Number one, even function and odd function. Even and odd functions. What is a even function? What is a even function? What is an odd function? What is a even function? What is an odd function? What is meant by an even function? What is meant by an odd function? Even function means if f is a mapping from R to R in the sense I want to take from A to R, where A is a subset of R. Instead of taking R to R, I am taking A. A is a subset of R, means some part of the real numbers I am taking. If A is a mapping from R to R, where A is subset of R, such that f of x equal to plus f of x, f of minus x equal to plus f of x, such that f of minus x equal to plus f of x for every x belongs to A. For every x belongs to A. If f of minus x equal to f of x for every x belongs to A, then f is said to be an even function. Then f is said to be an even function. Then f is said to be an even function. F is said to be an even function. An even function. Then f is said to be an even function. Means, for example, f of x equal to x square. F of x equal to x square, which is an even function, because if you find f of minus x, so what is it? Minus x whole square becomes x square. It is nothing but f of x only. So f of x equal to x square is an even function, because f of minus x equal to plus f of x. If f of minus x equal to plus f of x, then f is said to be an even function. Then f is said to be an even function. Now, even function is always symmetric about y-axis. Even function is always symmetric about y-axis. F of x equal to x square is a function like this. If you draw the graph of f of x equal to x square, it will be like this. It is a parabola opens upward. Parabola opens upward. Now, this is f of x equal to x square. Now, if you draw any horizontal line, if you draw any horizontal line, it cuts at 2 points. It cuts at more than 1 point, means 2 points. So, even function is always many to one function. It cannot be a one function. Even function can never be a one function. Even function should always be many to one function. Even function is many to one function. Is always many to one function. Many to one function. Next, even function is always non-periodic. Even function is always many to one function. Even function is always many to one function. and it is here f of x equal to x square is a polynomial, is non-periodic, but f of x equal to cos x, the same function if I take f of x equal to cos x, what about f of minus x? F of minus x is cos of minus x. Cos of minus theta is plus cos theta only, cos x only. So this is equal to plus f of x, means even function. So this is another example of even function. If you draw the graph of f of x equal to cos x, we already discussed in trigonometry. F of x equal to cos x graph will be like this. Means it is always repeated after every 2 pi units. After every 2 pi units. So this is periodic. So f of x equal to cos x is an even function but periodic. Here this is non-periodic. So what I want to say is it can be periodic or non-periodic, but it should always be many to one. If you draw the horizontal line, always cuts more than 1 point. So this can never be a one function. Even function should always be a many to one function. Next, if you observe these graphs again, one more thing, if you observe, I already told you, if you observe, this is symmetric about y-axis. Beginning what I told, f of x equal to x square is a parabola like this, open sum. So this is symmetric about y-axis. So what I want to say is, even function is always symmetric about y-axis. Even function is always symmetric about y-axis. Means if x comma y is some point in the first quadrant, then minus x comma y should be the other point in the second quadrant. So these two always like the first and second quadrants, always like the first and second quadrant. And symmetric, if x comma y is one point in the first quadrant, minus x comma y is another point in the second quadrant. Compulsory similar point will be there here. The same point will be here, like this. So x comma y minus x comma y. That's why we call it as symmetric about y-axis. Symmetric about y-axis. If you fold on y-axis, both will coincide. So x comma y always equal to minus x comma y. So like that points will be there in the even function. Next, coming to odd function. Coming to an odd function. F of x is an action A to R where A is subset of R such that f of minus x equal to minus f of x. F of minus x equal to minus f of x for every x belongs to A. Then f is said to be an odd function. Then f is said to be an odd function. So f of x equal to, instead of x square, if I take x cube, what happens? Minus x cube is minus x cube. Nothing but minus f of x. So f of x equal to minus f of x is an odd function. F of minus x equal to minus f of x, then f is said to be an odd function. Example is f of x equal to x cube gives you f of minus x equal to minus x cube equal to minus f of x. It's nothing but f of x cube is an odd function. How will be the graph of f of x cube? Graph of f of x cube will be like this. Means it is symmetric in the opposite quadrants. Means x comma y is one point, then minus x comma minus y should be another point. If x comma y is one point, then minus x comma minus y should be another point. So f of x equal to x cube is an odd function, and odd function is always symmetric in the opposite quadrants. Always symmetric in the, what I want to say, symmetric in the opposite quadrants means symmetric about origin. Same like this. So symmetric about origin means if x comma y is one point, minus x comma y should be another, minus x comma minus y should be another point of x comma y. So odd function is always symmetric in the opposite quadrants. Opposite quadrants. Another example you can take, f of x equal to sin x. What about minus f of minus x? Minus sin x. Sin of minus theta is minus sin theta. It's nothing but minus f of. So sin x is also an odd function. So if you draw the sin x curve, you know how will it be? It will be like this. So odd function is like this. Means here also, if you observe the graph of the odd function, it is symmetric in opposite quadrants. See, same term will be there on this side. So symmetric in opposite quadrants. Symmetric in opposite quadrants. Symmetric in opposite quadrants. So like this sine curve will be. So symmetric in opposite quadrants. X comma is one point, then minus x comma minus y is another point. Is another. So if you observe here also, it is not 1 1. It is many to 1. But here it is 1 1. So it depends. Next, what I want to say is need not be periodic. Here sin x is periodic and here x cube is non-periodic. This is periodic, this is non-periodic. Like this, it can be periodic or non-periodic. But symmetric in opposite quadrants is the property of the odd function. And every function can be expressed as sum of symmetric and every function can be expressed as sum of even and odd functions. Like matrix, we can express every matrix as sum of symmetric and skew symmetric matrix. We already did. Same property applicable here. Every function can be expressed as sum of even function and an odd function. Every function can be expressed as sum of even function and an odd function. Sum of even function and odd function. Sum of even function and odd function. So like this, we can discuss the even and odd functions. Remaining functions we will discuss in the next class.